Here's our second really important property that we can have for a function. This is the property of being onto, sometimes called surjective. If f is a function from a domain x to a codomain y, it is called onto or surjective if and only if any element in the codomain, if for every element in the codomain it's possible to find an element in x with the property that y is equal to f of x. Symbolically, that's saying a function going from x to y is onto if and only if for every y that's an element of the codomain there exists an x that maps to it. Well, there's several other ways we can say this. Basically, it's saying that there's an x value that maps to every single y value. Every element of the domain maps to, let me say it differently. Every element of the codomain has something that is mapping to it. Let's look at some examples, and I think that might help. Here are some arrow diagrams with some functions. Which of these are onto? Here, you can see I have a domain of a codomain of b. A maps to 1, b maps to 2, c maps to 3. 4 is an element that's in this codomain, but nothing is mapping to this one, so this one is not onto. Here, on the other hand, A maps to 1, B maps to 2, C maps to 2. Every one of these elements here in the codomain is the image of something in the domain, so this one is onto. Another way of saying this is that the codomain is the same thing, or it's equal to, the range of the function. If the domain and the codomain are the same thing, then it's onto. Over here in the first one, the range of this function is 1, 2, and 3, and that is not the same thing as the codomain. Whenever your codomain has elements where nothing is mapping to them, that makes it so it's not onto. Now, most of the functions you've worked with in the past have not been these finite sets where you have these arrow diagrams. They've been doing things where you go from the real numbers to the real numbers. If we look at f of x is equal to 2x plus 1, you can see that's a linear function that goes through 1 and has a slope of 2. It's going from the real numbers to the real numbers. Well, here, every one of the y values has an x value that matches it. So this one is onto. This function, however, where we're going to map g of x into its absolute value, gives you a V shape like this. Now, here you have some elements in the codomain which don't have anything mapping to them. For example, if you picked -3, there is no number that I can take the absolute value of and get a -3. It doesn't work. So we could find a counterexample here to show that this one is not onto. Now, an interesting thing about something being not onto, it's very important to look at the domain and the codomain of this thing. Here we said the range of this is going to be what? First, you might say it's all positive numbers, but it's going to include 0. So it's going to be all of the integer, I'm sorry, not all of the integers, all of the real numbers that are non-negative. Okay? Well, if you were to redefine this as some function h, and say that h goes from the real numbers to the non-negative real numbers, well then by restricting this codomain, we've made this back into something that is on 2.